without further ado, please welcome on stage Tali Barak.
Yeah. Right.
And there's this very strange thing because you are 25, right? But you're programming since like 40 years.
Yeah, started early.
It's very strange. Okay, so the stage is yours, and welcome to Angular Day.
Yeah, I need the time. Okay. Are you guys tired? Who's tired? Okay, then you're lucky that you don't have to be on stage and it's just me. Cool. Let's talk a bit about history, a bit of history. In around 6 years ago, and because I'm old, I remember things, we started with a thing about building web components, right? This became a thing. This is the PR, the commit on the React README, and it's from June 2016. I actually went and found it out. And this is the first time they are describing React as component-based, build encapsulated components. And even before that, this is December 2015, just prior to that, this is Angular 1.5. This is when they start talking about web components. And web components let you split your UI to independent, reusable pieces and think about each piece in isolation. And this is a really important thing. The important thing about components is their isolation, the fact that each one can be a standalone and work separately. And in those 6 years, we have improved a lot in our understanding of how to build UI components. We have all kinds of things that help us. We have state managers. We have practices about composition, presentational, and dumb and smart components, and what are the best practices. But I think that the one thing that we still miss to some extent is best practices about testing components. So, yes, my name is Tali Barak. I work at a company called Ubiq, and I'm going to give you an option to show you an option how to test your component using Storybook and Playwright. And yes, I am the person that submitted a talk into a conference in Verona and called it Love Story. That's me. I couldn't find it this morning, by the way. I walked to the old city and couldn't find it. Why now component testing? And when I tried to analyze it, I came up with 3 trends or forces that are now working that is actually pushing out in testing component in this way. The first one is importance of testing. Eda was here, was explaining why testing is important. I guess most of you have heard at some point or another a talk about testing is important, it makes your code more readable, it lets you refactor, blah, blah, blah. You probably already know all of that. So testing is important, and I take it for that you actually agree with that. By the way, how many of you are testing your component? Also, you know that it is important. Yes. I would like to, how many of you would like to test your component? Okay, fair. So at least you know it is important. Sorry. And testing your component also means testing in isolation. And here, I want to show you something. This is an application that is called Real World Application, or Conduit. It is a demo application that you can find on the internet, and it has multiple flavors of implementation from anything, Angular, React, you just name it, vanilla, whatever, and also a lot of implementation on the back end for pick your favorite technology, okay, from Node to Express, Laravel, whatever. And it's basically a Medium clone, okay, something where you publish articles and people can comment and like and so on. And today, I want to focus on this component. This is actually a comment component, okay? So it's basically, it's a very simple one because it's way too complex to show it on stage anyway, but you can write the code, it shows a picture of the user that is logged in, you can submit it, but there is also one thing, you can delete the comment, but only if it's your comment. You cannot delete someone else's comment. So if I want to test this component as an end-to-end test for testing my whole application, what do I need to do? I need to create 2 users, right? I need to log in with one, write a comment, then I need to check to maybe log out, log in again, log out with the other user, see that I don't see this delete that you can see here. You can see here the delete button, that I don't see it with the other user, that I do see it with this user. And if you try it and do that over an overall system, it's getting very complex. If to test in isolation, I just need to say, okay, let's say I'm a user, and we will see that later. We will get back to this component. The other thing that evolved, the second force, if you may, is the component ecosystem. We have a lot of things that happen that are supporting components. We have component libraries, you definitely know them. We have component-driven design. Our designers actually start speaking the component's language, right? They also know to specify components and not just pages. We have a lot of CSS tooling. It's very common in the React ecosystem that you have all this emoticon and CSS and all kinds of library that are supporting CSSing for components. We have packaging. This is not only for components, but also used for packaging components as libraries. We have state managers, which is part of what components need when they want to talk to each other. We also have components in the browser, right? Anyone here working with web components in some way? Okay, so you know that component is actually built into the browser, right? It's not just something external. But I think that one of the most important tools that we have for the ecosystem is Storybook. Storybook was built because we are working with component, and this is what it does. It allows you to showcase your component, see what they're doing, use it as documentation, have different demos. Storybook, who's working with Storybook? Okay, working, not want to, but actually working. Cool. And the third thing, and this is was already mentioned today, is about browser automation. Okay, so we also evolved a lot around browser automation. We have the old generation that started back in 2004. I was there, not sure about you. Tools like Selenium and WebDriver.io are the first generation. They use something like Web API, which is actually using the JavaScript inside the browser. And now we have a newer generation, tools like Cypress or Puppeteer or Playwright, which I'm going to talk about. Who have heard about Playwright? Let's see. Good. Oh my God. You are so lucky. You hear about Playwright for the first time. So the browser API, the way the browser API works, unlike the web API, is we have this is our different parts of the browser. Without going into too much detail, this is the render process. This is what you know as the page itself. We have here all the browser different processes, things like security, location, network. We have the service worker that is existing. And by the way, you don't. The reason I know this is the browser part is because Andre from the Playwright team has shown it. If you would put here a sandwich vending machine, I would still believe him that it's part of the browser. So whatever he says. And the way the browser APIs work is that they have an external process out of process automation that is controlling the browser. And this gives a lot of capabilities. on what you can do with the browser. It's not just running JavaScript. You can control the location, the network, the security. Basically, the browser is at your hand. The team that has developed Playwright has started doing it in Google as Puppeteer. This was the first, what we know as the Chrome development protocol. They started doing it, and later on, most of the team moved to Microsoft, and they took it and they used the same approach and technology in order to build Playwright. And Playwright, it's a browser automation. That means it's something that can control the browser. Initially, it was just a browser automation. It was called Playwright, and this is what it used to do. You can tell him, find this element, click on it, find this element, hover, find this input, put a name, maybe drag, mouse up, mouse down, and so on. But if you wanted to actually write a test, you would have to use one of the test runners that we are familiar here, things like Jest or Cucumber or Mocha. Anyone knows Cucumber? Never mind. That will be another talk. Later on, they extended it, and they built the Playwright test, which is also their own test runner that can run and replace things like Jest and Mocha. And they actually changed the name, and the Playwright, the browser automation is now called Playwright Library. So, as I said, 3 things that are impacting it. We are talking about the importance of testing, we are talking about the component ecosystem that is evolving, and we are talking about the browser automation. That's the groom. Let's bring the bride in. And the bride is our component. And this is what, it's great, but what do we need to test on a component? Okay, what are the things, what does it mean to test a component? So let's say this is my article component, and here are the things that I need to do. I need to check that the selector is there and it's actually rendering the component. I need to check the templates and the URL. So I want to see that my component looks like I hoped it would look like. I want to check my dependency injection, right? If I'm using any services, this is Angular. We want to check that the services that I passed are actually there. I want to check the inputs, right? We are writing components. Most of the time they have inputs. We want to check the different inputs, that it behaves correctly. I want to check the lifecycle events, right? We have the ng on delete, on destroy, whatever. So we want to check that they're running correctly. We want to check some of our logic. We want to check the user interaction, right? Click. We want to see that when we click, whatever needs to happen, happens. And also outputs, right? Inputs, outputs. And in this case, this is the output. We want to make sure that it emits the event. So these are the things that are needed in order to test our component. Input, output, services, methods, lifecycle event, layout, and user interaction. And the special thing about those last 3 is that they require the browser API. They cannot really work without the browser. They assume that they need the browser APIs. Okay, but how do we do that? So the first thing we have here, great, I just killed it, is we have our component code, okay? This is not something we can give to the browser, because this is what the browser will do in case we give it. Oh, no, I have no idea what to do with this code. I cannot run this kind of code. So the first thing we need to do is take our code component and build it to something that our browser can read, which is basically HTML and JS, okay? This is what the Angular compiler is doing. One way or another, of Ivy or not, at the end of the day, it's just simple HTML, JS, and CSS API that the browser can understand. The other thing that we did is to write our test. And this can be any kind of Mocha, Jest, Playwright, test runner, whatever. This is sort of like a schematic of how it does. We have a describe, we have a before each that we want to run for each of our tests. We have an it of what we are testing and so on. And again, this is not something we can pass to the browser. The browser will go and say, I'm not sure what to do with that. And for that, we need another things, right? We need the test code, and we need a test runner that will pick it and will know how to run it, and will know to run the before each every time I run a test, and so on. So we need to build our component. We need to run our test. We need to render the component, right? Not just the build. We need to actually render it in the browser. And then we need to execute our test. So I want to do this click and this hover and fill input and make sure that things happen. And then, obviously, when we execute the test, we want to show the result. And again, we are still in the same position for rendering and for executing, not for building. Building is done externally. But then if you actually want to render, we have to use the browser API. So you might go and say, okay, if you wrote tests, if anyone here would writing tests, and that's obviously not that many of you, you can say, but look, we already know that. We have the schematics. Angular is using Karma. We can write the test. It's true, and probably this is better than we are not writing tests. But the reality is that one of the reasons people don't write tests is because it's quite painful. I know I went through that with my team. It was pretty painful to do that. So how does Karma work? Okay, conceptually. Karma is a browser-only test runner. Okay? The whole 4 stages, except for the build component, which is done externally, Karma is effectively a web server. It runs very similar to your ng-serve. Okay? And the test itself, running the test, the whole it and describe, rendering the component and executing the test, everything happens in the browser. This is why the result in Karma, if you see that, we see them within the browser. And a browser-only test runner has some good things and bad things. The bad thing is that it's a very poor test runner. Because it's a web server, it doesn't really have access to the full file system. It doesn't know how to do things like parallel run. Okay? It is very limited in this side. The good thing about it is that it is really CSS. When you run Karma, you see the actual component. It really renders it. It is there. It's not some virtual thing. It's also compatible. For some reason, browser is compatible with the browser. It's using the API. If you're using the latest version, you have the latest browser API. That's good. It doesn't know how to do screenshots. And the reason it doesn't know it's because it doesn't have the file. It knows it can take the screenshot, but it cannot really save it to the disk. So it doesn't know how to do screenshots. And because it only inside this JavaScript window that we mentioned, it doesn't use the input part of the browser. It actually fakes the click. It creates fake events in order to emulate the test. So this is why you have to sometimes do like trigger, focus, and that sort of thing that do not exist with fake events, but they do exist with real input. So what are the other things that knows how to run JavaScript? And this all is JavaScript to compile code. Node.js, right? This is our environment. Okay, we have Bun and others, but for now, let's call them Endino. Let's say we are talking about Node.js. So Node.js came up with another approach, and if you use Angular Jest, which by the way was amazing until now, this is what it does. It is a Node environment. We use Node in order to build the component and run the test, but it doesn't know how to run a browser. Angular just does not run a browser. So what does it do? It takes a fake browser API. The most common one is JS DOM, okay, that emulates the browser APIs and uses it. So what do we get for this? And all the rendering execution are with the with JS DOM and the fake library. So we get a really good capable test runner because this is Node. Node can access file system. Node can run in parallel. It has all these goodies. But the browser mock or the fake browser has quite a few problems. It uses a fake CSS. It doesn't really render. You will get height and weight always 0 because it doesn't really calculate the dimensions. It has a problem with compatibility. The JS DOM community is doing a fantastic job in trying to make it up to date, but still, if you have like new APIs, you will find out that they are lacking, or if you're using like image tag or canvas or whatever, you will see that there are quite a few problems. You cannot take screenshots because we never rendered. There's nothing to take a screenshot of, okay? It's just an empty image. And obviously, because this is not a real browser, everything is fake clicks. And this is where we come with the suggestions, the idea. What I would like to suggest is that we can combine both worlds to get the best of them. And this means we can use Node.js and our browser. The Node.js will build the component and be our test runner, and then the browser itself will render the component and execute the test. And obviously, everything is nice and green. It's capable. We have its real rendering because it's using the browser. And it would be great to use it with Playwright. Playwright has a component testing, okay? They do that, exactly that you can test each component inside the browser, but it doesn't work for Angular. The reason for that has to do with the fact that they are using Vite as their build system, and Angular does not support Vite, so it does not exist. And this is the problem we had. We already see, if you look into Playwright, actually also Cypress has it, you will see that there is a component testing. They are bringing it to the table, but not for Angular. And this is our love story. This is what we did at Ubiq. We actually say, look, there is a tool that can build a component and render it. It's called Storybook. This is what it knows to do. Take our component code. We are writing a story that wraps the component code. Like this will be a same user. If you recall my comment one, so this is the same user. I will pass in some custom provider. I will do a fake user that will emulate whatever user I want. I will send the inputs of the component and set whatever I want in this data. And then Storybook uses Webpack, which Angular knows. It actually knows to look at your Webpack configuration in your Angular JSON. I'm not sure about NX, but in Angular JSON, and build the component, and this is what it will look like, okay? This is not what it will look like. I put it just in one page for clarity, but you see here I have two stories, a same user and a different user, and this is the same user with the little delete. I can see here that it looks like I wanted. It is not here. It is not blue or red or whatever. And this is another story where I injected a different user, and this does not have the delete. Okay, so very simple logic, but I can see here the two different stories. And on top of that, now that I have my story, first of all, I have the documentation. I have the showcase. I can show people. I can show my designer and tell them, look, this is what it looks like with the delete. Is that what you had in mind? Is that what it should look? Are the fonts okay? Whatever. I can do screenshot testing if, if anyone is doing that, visual regression, so I can take a snapshot and check that it was not unintentionally changed. Sorry. And then I add to this. Sorry. And then I add in inside that Playwright, and Playwright is taking my test and it's running it, executing, and reporting the results. So this is an example of a test in Playwright. Again, a very simple one. This test has a lot of fixtures, which is code that we have written in Ubik for our component testing. You can see the code. It is there. We shared it. You can see it in the repositories that I will show at the end. So I would say here it should emit event when this is clicked. So let's say go to the. I take the relevant fixture. I say go to the component and I specify the path that I want to go, because Storybook can actually show you each component on a page. Then I take the component. I can actually have access to the component, like do ng dot component, and when I access it, I can also do that in code and see all the properties, run all the methods. Everything is available, assuming this is a development build, but testing is fine to do in a development build. Then I attach an event, okay? I say when you emit a delete comment, because this is not this is Angular events, okay? We need to subscribe to them. We don't just listen like a browser event. So I can attach to the component the event, and then I do here promise all, because I have a race conditions. I mean, it has to make sure that it waits. So I wait for the event. I wait for the event to emit, and then I select my ion trash A. In this case, it's my delete icon. So I can easily this is Playwright, okay? I say find this element and click on it, which is exactly what I would do in a manual test. This will trigger the event, and then I will get it inside the comment data. Okay, this is what it was emitted, and then I can expect that the comment data will actually be what I emitted. So this is a full test on top of a story that is checking that I actually emit what I wanted. So it's actually checking my component. And I have the challenging part. Sorry. So I did not do a live coding, but instead I have very quick movies that will do that. So Playwright has a user interface that it can run. It's called VS Code. You can run the test directly from your VS Code. You don't need any other tool. So this is what I do there, and you didn't see anything because I was talking, but also because it runs really fast. It also, so you can see I just do a run test, and the next thing it opens. It can run also headless, so you don't have to see that this is mostly, otherwise I'll just show you that it runs and you see nothing. But I can also run, of course, from CLI, I can run on CI and so on. And you can see here that the test is actually passed, okay? But let's make it more interesting, and let's run it if I want to debug it, because it doesn't always work that great. So here you can see that I debug the test. I put a breakpoint, and now it runs. And I get, if anyone works with VS Code debugger, I get the same debugger. I can just go step by step, make sure that everything is working here. It shows me that, okay, here you see I found, let me pause that. Sorry, let me go back. See, it shows me here, look, I found the element you were looking for. This is the small delete icon. And then it runs, and eventually it will pass. Ed was mentioning, not only it has images that it can take and videos, it's actually something much better that is called traces, which is actually the DOM snapshot on every step. So you can go back into the DOM and explore it after the test has finished. So it's a great tool. So I am already past time, so let me give you just a really quick recap on this one. So components testing is getting really interesting. You should look at it. It's getting fun. So there's a good chance that you actually write it. It is what the good thing about this kind of component testing using Angular and using Storybook and Playwright. This is real component rendering. You don't need to mock anything. Stable test because Playwright knows how to work with the browser in a very effective way. It's very efficient. You can run in parallel, headless on your continuous integration. Everything is there. You can reuse the stories. So once you write the stories for Storybook, for your showcase and show people how to use, just use the same stories and run the test on top of them. This is just winning. Advanced debugging and tracing that I mentioned here already. And on top of that, you can do screenshot and visual test. It's a real, you can test, use one of the tools like Applitools or Percy or any other visual testing tools. Still something to improve. Angular Storybook in general is working well, but I think there's some place for improvement there, especially about Storybook speed and Angular component testing on Playwright. If we will have that, it will be like, wow, this is the winner. Where are we on component state? So we have Playwright component testing that I mentioned. Storybook also are trying to add some testing capability with the play and run function. Cypress has component testing, including Angular. So if you're working with Cypress, which you should not, but if you're working with Cypress, go ahead and check it. And that's it. This is the repository that I've mentioned. Thank you so much. Thank you. Julia.
Thank you.
Ah,
You're perfect time.
on time. Amazing.
Yeah, you're on time.
Yes.
Thank you.
Okay.
So, any question for Tale? So, don't be shy.
So why would you use Playwright over Cypress?
Ah. Why would you use Playwright over Cypress? It's a long answer, and also I really don't feel comfortable understanding it. I would just say that Applitools has run in two head-to-head fights. One was last month, and another one was like in May or something. I'm not really sure. You can check that on the Applitools website. And they were bringing two people, Andy for Playwright and forgot the name, I apologize, from Cypress. And they were doing head-to-end, and you have the result there. Let's assume it's a football match, so I won't tell you what the results, but it was not Cyprus. Let's put it this way, both matches. So all the answers there, otherwise, I mean, I can have an hour and a half talk just explaining that.
Thank you. Yeah, another applause, right?
That was the only question?
Questions, folks? No?
Was it so complex? Was it so boring? Was it so clear? One of them should be right if you don't have any questions.
Probably very clear.
Really? Wow, nice.
Yeah, it's good.
Okay.
Oh no, we have a question.
I have a question then. Do we have time? Oh, okay. I saw it.
Why don't you use Jest to snapshot testing?
Just snapshot is not really visual. It's just it just records your HTML. So it's good for verifying that things change. But sometimes, what you really want is how it looks, because it makes sense that you would move the style from one place to another. Maybe you now use, I don't know, REM instead of PX or whatever change that you did. So your Jest snapshot will fail, but your component still looks perfectly fine. So it's always better to do the visual, because this is the close to the user. The user doesn't really see your PX, REM, or whatever CSS variables you use or whatever. It is a screen. That's why I would, visual testing is much better in this sense. Not to mention the fact that Angular is adding some Angular version, so all of the tests fail, so you don't know which one is real. Don't use it.
Hi.
Hi.
Just asking if there is.
Of course, that's what we do here.
Yeah. If there is like a plugin or something for Storybook to have like the test listed inside the panel, and maybe I can run it directly from Storybook.
Okay. Storybook has it for its own. It has something like that for tests, but it doesn't use Playwright. It uses their play function. They don't use Playwright. I think they will, and very soon, because Playwright is solving a lot of the problems that we have really in the browser. One example is that if anyone did end-to-end testing, that it takes a bit of time for the, let's say you have animation, okay? Animation was a huge problem. It still is if you're using Selenium, because it tries to click the button here, but the button is already over there. Playwright solves it. It knows to wait for your screen to become stable with animation, and only then it will try to click on the button where it should be. And Storybook are using testing library, which is again aimed for a mock and not for a real browser, so they still suffer this kind of problem. So again, write testing, but I think this moves it to a whole new place where it's much more convenient to write it. We are done.
Thank you.
Thank you.
We have time. We have actually time for very quick. Okay.
Okay. Another applause. Yeah.
Yeah, I see that in all example in your presentation, and also in the example of other presenters, all selectors or element selectors are done with CSS selector and not with accessible selectors like the title or something that the users can see. Is this only for a demo purpose of presentation, or there's yeah?
I like this question. The answer is yes, you're right. The selectors should be based on what the user sees. In my example, it was an icon, so obviously you cannot do text, but Playwright has excellent text selectors, and this is what you should use, again, because it's close to what the user sees. So you can use it, you can even use regex to find it, you can filter, so if you have like rows, a lot of capabilities, and you can combine them with CSS selectors, and you can combine them with XPath, but don't do that. And I don't remember, but they have CSS and they have text, so you should use it. In my example, it was just an icon, so obviously you cannot test it any other way.